Good morning, my name's Mike. I've got, despite my youthful looks, almost 40 years experience in asset management, reliability, inventory, maintenance, predominantly in the oil and gas industry, offshore and in refining, but also a bit of power gen. So today, I'm talking about finding the right parts in the right quantity, right time, right place, right condition for the right cost in an uncertain world. I'd like to thank my co-author, Paul Shoesmith, who's not here. He's freezing himself in northeast Scotland at the moment. So I am going to set you a challenge to see how many rights of inventory, MRO inventory management you can come up with by the end, and I'll come back to you. And if you stay to the end, I'll give you a bonus tip as how you can turbocharge your inventory optimization. So first of all, why would we want to optimize our inventory for maintenance, repair, and operations? Most organizations have objectives that fall into these three main categories: health, safety, and environment, revenue or production availability if you're not a profit company, and cost. And we don't want to harm any of those. And generally, spare parts, lack of a spare part doesn't have a safety impact in most cases, although there are one or two, like a spare wheel on a fire engine, for example, that takes that out of action. Normally, you can shut down production to avoid the consequence. In the Goldilocks zone, we have just the right amount of inventory, not too many, not too few, and just for the right cost, and it has zero impact on our goals. But in the real world, that's not what happens. So we can have too many spare parts, and I've listed 7 reasons here. I won't go into detail on all of these things because of the time, but one of the ones I'd like to pick out is what I call squirrel stores. Those are one where maintenance doesn't trust the inventory, so they have their own spares in their own stores. We're not controlled, so we don't know how many we've got, how many we're using. We also don't control the condition of them. If we put something in that we don't know the condition of, that can have an incident that we don't want to have. And cuckoo is something that's a spare part for something we don't have. The other extreme, we can have too few. And what you'll find is that actually some of the things that say too many actually can also make us have too few. The big one we want to avoid is putting in a spare part that's in unusable condition that we don't know about. And I've seen that happen. And you don't want a gas compressor having an explosive decompression O-ring that's past its due date that you didn't know about. But as with the previous speakers, what we want to do is make sure that we can find those spares, that we don't have spares on the shelf. So that we might have them, they might have an excess number because they're unusable, but the ones we need aren't there. Those holes generally affect revenue first. The excess generally affect cost first, but there's one or two, the squirrel stores and the hidden unusable spare part that can have a big impact. Those are the things that can take down a plant or cause a big incident. So we want to avoid those as far as possible. So how do we go about doing that? So in a turbulent world, before we worry about the turbulent supply chain, we have to get the fundamentals right. And I split that into 2 main areas, first of all. Managing the data right, which we've been speaking about before, and managing the spares right. And again, our previous speakers were talking about this. I'm going to focus mainly on the data because of time, and I regard data as the lifeblood of inventory management. If you don't have this right, then you're going to struggle with every other part of the process. So first of all, we need to have our asset master data right. We need to know what assets we've got, where they are, what they do for us, what's the consequence of failure, how can they fail. If we don't do that, then we're in a difficult position to start off with. I've given you some extra information on the screen that I'm not going to go through, but it is key, as the previous speaker said, to use data standards, have a standard way of recording the data so that we can identify things easily and make sure we're not duplicating things. Once we know what we have, then we need to know how we intend to repair the equipment on certain types of failure. This affects what we want to hold. And that might vary by the class of equipment, what it does for us, how it fails. But what we're really asking ourselves, when this fails in this way, are we going to repair it, we're going to replace it, or do we leave it to somebody else to do? And that will affect what parts we're going to hold. If we say we're going to replace the unit as a whole, then we don't need component parts. If we're outsourcing it to a third party, we might not need to hold any spares at all, but we might want to catalogue them in case we decide we don't like that third party contractor and we just put all our eggs in one basket. So now we know what we have and how we intend to repair it. So then we need the catalogue of material masters that lists all the spare parts that we want to hold or might want to purchase. We should really align that with our repair strategy and not just buy everything that's on a bill of materials that we can use to build a piece of equipment, which is quite often what we get, which normally leads us to holding too many of the wrong thing. Again, we should have a main data set and common data standards. I've listed some sources that I'm familiar with from the industries I've been working in. The main aim is not to duplicate things. And my colleague Paul Shoesmith has had one instance, we had over 200 instances of the same item in the same catalogue, which you can imagine the problems that causes, both in overstocking and having spare parts not available when you need them, even though they're on the shelf against other pieces of equipment. It's a big job to deduplicate, and what we have found, proper use of machine learning and large language models, coupled with a subject matter expert, can really speed up the process and improve the accuracy so that we can actually do it in a reasonable time rather than spend years and years and years doing it. Some organizations have hundreds of thousands of records, and at 100 records a day, that's going to take you a lot of time or a lot of people. So once we have our catalogue, then we need to know where we're going to use that catalogue, otherwise it's not very useful for us as maintenance people. So our bill of materials helps link our assets to the equipment, and sometimes it helps link our repair activity. So if you have a maintenance bomb, so for a particular large piece of maintenance work, we might identify all the spare parts and consumables that we need for that repair. Again, that allows us to use the same parts on multiple assets. If we go back to the OEM, the original manufacturer part numbers, not the supplier part number, there's lots of pump and compressor manufacturers that give us their own bearing number and their own seal number. But if we go back to the OEMs, we can use those and hold less. If you don't have the bill of materials, then when we have a failure, then we're scrabbling around to find what we need, and quite often we're ordering things we've already got on the shelf that we don't know about. So that's a very quick overview of what we need to hold. It is only a what to do, not how to do. But there's not time to go into any more detail, but feel free to ask me questions afterwards. Then we need to decide how many do we hold. Again, this will be a brief overview. First of all, we need to establish the demand for our spare parts. And here, what we're really looking at is the spare parts we use for repairs and breakdowns. The ones that are used for projects and for planned maintenance, we know about those, we can plan those, but we're looking at the uncertain usage. So we need to look at our maintenance work orders and try and classify those into repair work orders. Sometimes they're still strange though, and it's good to look at the data graphically, and if you see a spike where you use 12 of the same spare part on the same day, then I'd look into that, because that's not normally how things happen. That's probably somebody putting a new system in. And they can, by all means, use the same bins, but we need to identify the numbers properly. Then we want to try and fit some sort of distribution to it rather than a number. If you use a mean time between failure and a mean lead time, there will be tiers, because most of the time you won't have the spares that you need. And just be wary, there are other types of inventory than MRO inventory. If you use algorithms that are used for manufacturing or for selling of finished goods, then that's going to run you into trouble as well, because the mathematics is normally different behind those. Actually, I should have mentioned, demand can be affected by the turbulent supply chain. Because things are changing, then we might have to drive our plant harder or shut parts of the plant down. So just be wary about the data we're using, understand what it means, and we might have to make some estimates. The past isn't always a picture of what's going to happen in the future. We just need to understand what that data is. So the supply chain turbulence hits here. The lead time, that can be difficult to predict. We can use past lead times, but we need to have a bit of caution here. Sometimes, again, we might have to adjust the figures, make some estimates. Again, we'd like to use a distribution rather than a number, because what we're trying to look at is getting in our model, meeting a service level. So for different levels of criticality of equipment, we might say for a high criticality piece of equipment, we want a 90% chance that when we ask for the spare part, that's going to be on the shelf. A lower criticality piece of equipment, we might accept a lower service level. So we want to have some sort of model that allows us to understand what our chance is, how many we should hold. And we need to test that model. Because our numbers, wherever we get them from, will be guesses, maybe intelligent guesses. We need to do some sensitivity analysis to make sure If we change that number by 1, does it change the results drastically or not? If it doesn't change it drastically, we're probably okay. And again, effort here. This is a big job, so don't do heroic efforts on the low criticality, low cost thing. So put the effort into things that really matter, have some rule sets, say anything below a certain value, below a certain criticality, have some standard rule sets to get those out of the way and focus the time on the things that really need it. For example, if you're deciding whether you should hold a spare gas turbine, which might cost you several $1 million, and it's something you don't have a usage for, it's a capital spare, then you might want a much more detailed model using Monte Carlo simulation to understand what the possible outcomes are and whether you should hold 1 or 2. That's something we do in the oil and gas industry quite a lot. So that was managing data very briefly. Managing spare parts right. A lot of that was covered in the previous presentation. That makes that easy for me. But we need to, once we've got the spare parts on site, handle them properly. We need to buy them from the right source. We need to control the warehouse properly so that we know what's happening to the spares, where they're stored. We need to receive them properly, get the right documentation. So if we've got certificates that will expire, we know that things have expired. We don't use them in our machines inadvertently. Store them properly so they're not damaged. Maintain them if they need maintenance. Issue them properly. And then if spare parts come back into stores, and this is quite critical for not getting the hidden or obvious unusable spares, don't just take anything that comes back from site and put it back into stores again. The number of times we found the part that's just been removed on the shelf, when you come to use it, it's not usable. I'd be rich if I had $1 for every time that was done. So what we don't want to do is return things that have been removed from the field into stock, at least without going through a quarantine process. Right. So we've done our 2 main foundations, but I want to add 2 more fundamental foundations as we're approaching the end. First one on the data side. Once we've established all our process for data, we need to govern it right. So we need to stop people that shouldn't be changing things from changing things. So it'll mean some pain. So at the moment, you might have hundreds of people have access to your CMS and can add a material master and change things. You don't want that happening because you'll spend a lot of money and time getting it right. You don't want it to all be undone in the next year, 18 months. So you need proper processes, probably a data owner that governs who adds things, how they can add them, and what checks do you do before you do that. Other thing is, there is not strictly to do with the spares, but once you've looked after it all the way through the system, you've got to install it right. So you need the right processes to make sure that it's in place. Right, whistle stop. We have a 5-step optimization process that we use that involves focusing at the outset as to what we're trying to achieve, engaging a whole range of stakeholders, analyzing the data, standardizing that data so that we have a common understanding, reviewing that with the stakeholder before we decide what to do. And there's lots of different things we can do. I've listed 5 potential quick wins, but I know I'm running out of time. So those are quick wins in my area. In your arena, it might be something different. It depends on your own objectives. What's your biggest pain point? And we have a range of tools and processes that we use, and there definitely won't be time to go through these, but you can ask me about them later. So I'm just wrapping up because I know I'm going to be getting to the end. I promised you a bonus tip. So the bonus tip is that in an ideal world, we would, in the Goldilocks scenario, we would have 0 inventory. If you look at the 10 rights of asset management, where does the inventory come in? Is it in the back end of step 7? If you look at the SDIPF curve, inventory comes in right at the right-hand side. There's lots of things we can do first before spares become the issue. So what we want to do is drive down the spare parts demand, because then that makes the turbulent supply chain less important, and we have to do less work, and we have to hold less spares. And the uptime elements is where we can start for that, primarily with the technical aspects first of all, and probably defect elimination would be the good one before moving on to the leadership and the processes. And in finishing, I came up with 10 rights of MRO inventory management. That's for a good reason, because they're 10 rights of asset management. You could have come up with any other number, less or more, but here's my 10. 4 foundations: manage data right, govern data right, manage spares right, and install right. And that gives us 6 right outcomes. Right parts, right quantity, right time, right place, right condition, and right cost. Thanks very much for listening. Hopefully I've got you thinking a little bit and wondering, what could we do in our plant? Supply chain turbulence affects all of us. There are things we can do, even though it's difficult, but it's more about eating the elephant one bite at a time and not trying to solve world hunger all in one go. So that's my time up. Answer questions. I'm on the on the event app. My email's at the start. I'm on LinkedIn if you've got other questions afterwards. Thanks very much for your time.
Thank you, Michael. Does anybody have any questions?
So on one of the slides, I forget which one it was, it says for demand, why there was a statement that said exclude projects and PM spares. I get it, for projects you don't want that to be in the demand calculation, but why not PM spares?
Well, PM spares are predictable. They're coming at a fixed location, where the spares for repairs, the time to failure is normally random, so you've got two different distributions you're mixing. So when we're doing our analysis and thinking our distribution, we don't want something that's coming at 6 monthly, 3 monthly, 12 monthly intervals coming in with something that's a random process. We still account for them in the bin. They go in the same bin, but we don't mix the two types of data, because what you'll end up doing is holding more spares than you need to. Because you can always, if you know you need a spare bearing every 6 months, you can always place an order for it. You can hold it in stock, but you don't need to do it separately. And the new one, where they install 12 new wells and install 12 new valves, you definitely want to make sure that, this is a real case, that you don't count those 12 as a usage, because that will definitely distort your numbers, and you can hold several times more than you need to.
Anybody else? I think you're off the hook.